First idea is that it has an ice surface covering a warm convecting ice ocean, whereas this one has the ice covering a liquid ocean. And that's how you get the young surface, because it's either ice that's convecting or liquid water, or not liquid water, but liquid. That means that the surface is constantly moving around and renewing itself, so it can never really age. All right, and these are the missions that we've seen to Europa, with Pioneer 10, 1973 being the first mission. And this is where we get this picture. This is the first picture we've ever seen of Europa. And this is the next mission. This is the European Space Agency is sending out the JUICE mission, which is actually going to Ganymede. But JUICE stands for the Jupiter Icy Moon Explorer, and that should happen sometime around the mid-2020s. And then NASA actually has another mission planned just to go to Europa, which is named the Europa Clipper, and that should also happen sometime in the near mid-2020s. Right, and now we have
Take the iPad. Hi everybody, I'm Robert Jarvis of Little Falls, and I will be presenting about Enceladus. Enceladus was discovered by William Herschel on August 28th of 1789 rather. It was named after Enceladus, the giant in Greek mythology. Now what's interesting about Enceladus is that in this picture you see he's kind of struggling to get out of some rubble. How the story goes is that he was fleeing from a battle and Athena threw the island of Sicily at him, and he was buried underneath it.
Sure.
Enceladus is the sixth largest moon of Saturn with a diameter of about 310 miles, so it could fit about inside Arizona. And the average temperature is about negative 330 degrees Fahrenheit. Very cold. As you can see over here, we have a comparison of Enceladus is that small dot, then Luna and our Earth. And here we have some other moons to compare the size of. There we go. It orbits Saturn at about a distance of 148,000 miles. Its orbital period is 33 hours. A speed of 28,265 miles, and 100 pounds on Enceladus would weigh about 1.13 pounds. Nice. Lose some weight. Here we have kind of a cross section of what Enceladus is, with a rocky core. So it has a very reflective surface, like Joe said about the, they think there's a liquid ocean underneath its icy crust, so that it would constantly renew itself. And it's a very reflective surface due to that young surface as well, as young as 100 million years, which, again, sounds like a long time, but in terms of our solar system, it's quite young. And as you can see here on the poles, there are plumes of vapor, and on the Voyager 1 and 2 flybys we didn't see that, but with Cassini when they flew by they saw these vapor plumes. What's interesting about these is these are caused by hydrothermal vents underneath the surface around a wet reservoir, mainly methane, propane, and water. And what happens is as it heats up it shoots out just water vapor from the through the crust. Here, we're excited.
Enceladus is not very big.
No, it's very
Why is it not just frozen solid?
because of the hydrothermal vents underneath it.
Really? Crazy.
So you said your moon, I don't know how to say it, has a very reflective surface. Would that just be for mainly like light rays, or could that be for like almost like a mirror for us? Or
Mostly
not?
light,
Oh.
light rays.
Any other
With all
questions?
those balloons happening, I'm wondering, why doesn't it run out of water? Eventually, all of it should evaporate or disappear, shouldn't it? Does it fall back down to the surface in snow?
I don't know,
Some of it does, yeah.
probably.
Yeah.
Very slowly.
Those moons, in particular these three moons, we're really interested in these moons. Titan has a massive amount of hydrocarbons and water. Enceladus has some hydrocarbons and a lot of water, and Europa has a lot of water. And what we're looking at with those moons, if we're gonna look for life in our solar system, these are the top three places to go, and I'm not sure which one I would rather go to. But if you have hydrocarbons, okay, if you have methane and ethane and these kind of molecules, and the combination of water, you have a chance to make, amino acids. Okay, amino acids build proteins, proteins build DNA. You with me? And so if we're gonna look for life, these are for sure three near the very top, or if not the top of the list of places we're gonna look for life. And so it's really cool, you know, we're looking way out in the galaxy for life. It's on these moons, it has to be. I mean, there has to be some kind of microbial life on one of these moons. It just, I think the chances of it, of those moons not having life, it just seems to me like we just need to go there and look. Now you need a big, long auger to drill through the ice.
But
Your cold volcano.
So, the way I think it is, or the way I think it happens is, water mixes with ammonia, that makes like a magma. The tidal heating from Saturn causes this to turn into a liquid, and it kind of works like a volcano.
So it's not plate tectonic.
It's not
Really?
plate tectonics, really.
It's
Volcano.
salty water too, I believe.
Yeah.
So it's, between the gravitational tug and the fact that it's salt, it can remain liquid to a fairly significantly low temperature.
Go ahead, Europa. You said there was a mission going in 2025, NASA had?
Yep.
Last time. You know anything about that mission, what they're planning to do? But I remember reading about something where they're gonna drill. There was gonna be an auger, and they were actually planning, like a little submarine.
Yeah, and I think that's it. It's called the Europa Clipper.
Is
And
that
I believe
mission
what they
is
want to
that-
do is they want to send it there and not and take samples of the surface and kind of see if they can get below that icy crust to see if there actually is either a liquid ocean underneath or just a frozen layer of ice.
Yeah, they have a few proposals on that. One of them is to have like a glider, the other one is a hot air balloon, the other one is some kind of a
So,
surface. And I think they're all potential right now, I don't know if they've really decided, but it's fascinating, absolutely fascinating.
Okay, so, there's a lot of different kinds of salts in chemistry class. So
Mhm.
like, is that salt water the same as our salt water?
Possibly, it's silicates and yeah, carbonates, yeah, similar to what our salt water